Hey, what's going on, guys? We have this question that is asking determine the normal force, shear force, and the moment at point C. So this is the point we need, but before we go for that one, we put the forces, possible forces here. So AY is gonna have two forces, AY and AX, and for B only one force is possible. That's gonna be BY. And now I can solve for by because a has two unknown variables and b has one unknown. So if I take moment around a, I can get rid of these two unknown and I can solve for b. So let's do that one. So ma is equal to 0 and sigma ma is equal to 0, and if I take counterclockwise positive and solve for this one, I will get 12 kilonewton pushing this object down. Therefore it's clockwise. 12 times 1.5 minus, and 9 kilonewton. Actually this is going to be in the middle, so the this means it's equal forces acting on this. So I can write it as one force in the middle, so that's going to be 9 times the distance 3, so it's going to be 27 kilonewton in the middle. So I can say it's acting clockwise, therefore it's going negative 27 times. This is going to be exactly in the middle, so it's going to be 1.5 distance. So 1.5, 3, 4.5. So 4.5 from A. So it's going to be 4.5. Then we have By pushing this object up, so it's acting clockwise. Therefore it's going to be By times 6 meter equal to 0. And if I solve for By, I will get 23.25 kilonewton. So this is the answer for By. Since we have the By, now we can cut this part off and solve for other things. So if we cut this part, let's see what happens. So if I cut this part off, but in this case we have to be very careful because when we cut this part off, the equal forces is going to be still coming, right? So it's going to be equal forces here. So this is going to be 9 kilonewton per meter still coming, and this is going to be my C, and the distance is 1.5 and we have By right here. So now we have to calculate this the middle force again. So to calculate it, I have to multiply this 9 by 1.5. So if I multiply, I will get 9 times 1.5, which is going to give me 13.5. 13.5 exactly in the middle, so it's going to be 0.75 meter distance. So I draw this again. Take this one, so it's going to be, so we are going to have 13.5 kilonewton in the middle, and the distance is going to be, this is going to be 0.75, 0.75. So these are the distance, and we have C. The question is asking find the normal force, shear force, and the moment at point C. So let's say normal force is NA acting on this side, and I can take shear force whatever the direction you want. So if I take this side, let's see what happens. So it's a, you can assume the direction, and if you get negative, it means your assumption is wrong and the direction is opposite. So that's all we have to know, and we know we need to know normal force, shear force, and the moment around C. So if I take moment around C clockwise, I can, this is also assumption, right? And now I can solve whatever I can. Okay, I have also By right here acting upside. and then this is it. This one VC and NA, that's it. So I can directly find NA because that's the only horizontal force. F of x is equal to 0, and since there's no other horizontal force, NA is going to be equal to 0. So this is my answer for normal force. Then we can find the VC. So sigma F of y is equal to 0 in statics, and if I take upper direction positive and solve for this one, VC is going to be negative VC, and this is going to be negative 13.5, and By is going to be positive, and we know By already 23.25 equal to 0, and if I find the VC, which is going to be equal to 9.75, since the answer is coming out to be positive, then therefore the direction is right, it's acting downside. So this is the answer for VC. Then I can find moment C. So if I take moment C and solve for this one counterclockwise direction, if I take counterclockwise positive, this is going to have 13.5. This is acting clockwise, so it's going to be negative 13.5 times 0.75. Then By is pulling this object in the clock. This is pulling counterclockwise, so By is 23.25, so it's going to be plus 23.25 times the distance is 1.5, and we are assuming this MC is acting in the clockwise direction, so it's going to be negative MC equal to 0. Now if I solve for MC, I will get 24.75 kilonewton meter, which is negative. So therefore I know this MC is acting clockwise. So if you keep the negative sign, it already representing clockwise, or you can write it as MC is equal to 24.75 kilonewton meter, and you can put the direction straightly here, and that's going to be the final answer. And we have found shear force, normal force, and the moment at point C. So that's all we need to know, and I hope you guys like this video. See you next time.